Hey guys, what's up? Let's move on with our physics lecture, and today we gonna study the second equation of kinematics, and that is S is equal to S naught plus ut plus half at square. So let's just derive this equation. Now we have two equations here. One is dv by dt is equal to a, that is the rate of change of velocity is equal to the acceleration, and ds by dt is equal to v, that is ds the rate of change of distance is equal to the velocity. So now let's just start with the equation. We can do this derivation using the last formula too, but I'm starting from the basics, right? So we have dv by dt is equal to a. Okay, so we write it here, dv by dt is equal to a. This implies dv is equal to a dt. Okay, now what we do, we integrate both sides. So integrating both sides, we integrate both sides, right? And that's what we get. We will get v on the left hand side, v is equal to at plus the constant of integration, which we calculated as the initial velocity in the last derivation. Therefore I can directly write v is equal to u plus at. Now we write v. Here this v can be written as ds by dt using the second given equation. So I will now write it as ds by dt. So implies ds by dt is equal to u plus at, right? Now we again cross multiply dt and we'll get ds is equal to u dt plus at dt. Now again we say integrating both sides, integrating both sides, will get, and the left hand side will get s, that is the distance. S is equal to u dt integration will be ut plus t dt integration will be t square by t. So the second term will be a t square by 2 and plus the constant of integration. Now let us find the constant of integration. So finding constant of integration, we will take the initial values that at t equal to 0, let it be at some distance s naught. So what we do, we say at t equal to 0, s is equal to u0, s naught, we'll write s naught, that is at t equal to 0 it is at s naught, and u into 0 plus a into 0 square by 2 plus c, right? So what we'll get c is equal to s naught. Therefore the constant of integration is the distance at t equal to 0. Therefore at last we get the equation as s is equal to s naught plus ut plus half at square. So that is the second equation of motion. So that is a derivation using the basics, like starting from the basics. You can also derive this equation from the first equation of kinematics too.